So this lesson will cover proportional relationships, and we can use this to help us prepare for the study Allen test that goes along with proportional relationships. Um, this topic actually covers quite a few standards, um, since the seventh grade standards for math have a lot to do with proportional, using proportions to solve problems, setting up proportions, and those sorts of things. So Jake is traveling 12 miles per hour in his boat after 5 hours. How far will he have traveled? Well, we can say 12 miles per hour is 12 miles per 1 hour. Again, we're putting the miles on top and the hours on the bottom. So if you set up a proportion doing this, we would put 5 hours on the bottom and put an X on the top. Now, if you notice here, to get from 1 to 5, we multiply by 5. So if we just multiply 12 times 5, we're going to get 60. Okay, so our correct answer here would be D, or 60 miles. The seventh grade choir sold pizzas as a fundraiser. The choir teacher created the graph below for the students. So based on the graph, what is the unit rate of profit for the pizzas? Okay, so in order to find the unit rate, that means over 1. So however many pizzas, or excuse me, dollars, has to be over 1 pizza. Okay, unit means 1, and so we want to figure out over 1. Now, in order to do this, I need to find a good spot where it intersects. So right here, it intersects both the X and Y axis. So that is $18 and 10 pizzas. So what I have is 18 over 10, and whenever I divide by 10 to get it over 1, just move the decimal one spot to the left, so that'd be $1.80. Okay. So again, setting up a proportion here, right now it's over 10. We want it to be over 1, so simply just divide 18 divided by 10. But again, just showing here how all these problems can be set up using proportions. Adam bought a new video game. He graphed the points he earned below. So what is his rate of points per minute? So again, this is kind of talking about a unit rate. We want per 1 minute. So time is right here, minutes. If I go up, this is where it crosses, it comes over. We see that it's a 1. But then I have to look at my label on the side, okay? So it's actually 1,000. Okay, so 1,000 points per 1 minute, or per minute. So you could answer, now these would be multiple choice here, but get cut off. So 1,000 maybe points per minute if it was something like that, okay? Next question here is, what type of function is graphed below? So whenever we see lines that look like this, we call that an inversely proportional graph. Okay, so I look here as x increases. Okay, x is getting larger. You know, it's going from 1 to 2 to 3 to 4 to 5 to 6. What is happening to y? As x increases, y is getting smaller. Okay, and then we can look at that the other way, inversely, and we could say that as x decreases, well, then y increases. So we would say that's inversely proportional. Now, you might ask, well, what does a directly proportional graph look like? Well, that would be a graph of a line going straight through the origin. Okay, going through the origin is key. And so as my x increases, my y is also increasing. Okay, so as my x is getting bigger, 1, 2, 3, 4, 5, my y is getting bigger, 1, 2, 3, 4, 5, and it goes right there through the origin, 0, 0. So that's what a proportional graph would look like. Inversely proportional, this would be an example of that. Which of the following is an example of an inversely proportional relationship? So again, as one thing increases, the other is going to decrease. That's what we're looking for. So the more candy bars Tyler buys, so that's an increase, more, the higher, and that's also an increase, more. So we have 2 increases, so that's not going to work. So A is not a good choice. The faster Maya walks to school, so the faster Maya walks to school, that's an increase, the sooner she will get there. Sooner means it's going down. So here we have opposite directions. So I like B as my choice, but let's keep reading. The more light, again, more, means an increase here, so this is going up. Sammy shines on the bean plant. The bigger would be increasing, so these are both increasing. And the lower the rain total at Lake Sheboygan, the lower. So these are both going down. So again, I still like my choice for B, but it's good to read through all your options. Catherine recently had a swimming pool installed in her backyard. Using her water hose, she can put 75 gallons of water into the pool every hour. So again, kind of keeping an eye on those key things here. So 75 gallons per 1 hour. If the pool can hold 13,500 gallons, how long will it take to fill the pool? So I got to keep my gallons on the top. So the 13,500 is going to go right here because that's my gallons. And how long will it take? That's got to be my X right here. So we're going to look for hours. Now my hours do match here. These are all hours, so we're good to go here. Again, as normal with proportions, we cross multiply and then divide by the coefficient. So 75 times x is 75x, and then 1 times 13,500 is just 13,500. Got to divide both sides by the coefficient, which is 75. And so 13,500 divided by 75 gives us 180 hours. So that would be our answer right there. Going on to the next one, the table below shows the cost of fresh lettuce at the farmer's market. Based on the information in the table, what is the price per pound? So we're looking for price per pound, per 1 pound. Okay, it doesn't say per 2 for fresh lettuce. So here's 0, 2, 4, 6. So these are all going up by 2. So for 2 pounds, I get 188. And I want that out of 1 pound. Okay, so from 2 to 1, we basically just need to divide this by 2 to find out what our X is. Or you could cross multiply and you do the same thing. So $1.88 divided by 2 is going to give us 94 cents if you go ahead and do that with your calculator. The graph above shows the revenue generated from computer sales. Daryl is New Tech's leading salesman and just received an order of 8 computers. Based on the graph, what is the total revenue generated by the sale? So we have revenue in thousands of dollars over here, so that's your label, thousands, and then computers sold. So we're looking for 8. Now 8 is in the middle here. Well, it's actually not even in the middle. It's like 2/3 of the way between 6 and 9. And so we could kind of look up here, but it would be a guess as to where it is. You know, is it exactly 10? Not really sure. So again, I'm looking for an intersection. So this is not intersecting here. This one's not. This one's not. Oh, we have one intersecting with a line. Now, you usually in these types of problems, you're going to have one intersecting. So I'm going to put 15 over 12 because I always put my y values on top of my x values. So I'm going to put 15 over 12. And that's equal to, now remember we're selling 8 computers, so 8 goes with the 12 here, so I got to put the 8 on the bottom, and x goes on top. Now if I cross multiply, I'm going to have 12x is equal to 8 times 15 is 120, and then when we divide by 12, we're going to get x is equal to 10. Now, remember, 10 is over here, so it was right on the line. So this spot right here is the spot we're talking about. But it's good for us to actually find the actual amount by using our proportions. Now, remember, 10 is not just $10. That's $10,000 because it says in thousands. Okay, so there's your answer. Does the table below represent a proportional relationship? Remember, proportional would mean they're both going up or that they're both going down. Also, it means some other things as well, okay? In order to find out if something is proportional, we need to find out if they would create equivalent ratios, okay? We've talked about that before. Proportional means equivalent or equal. So let's check this out. Now, I always put y over x when I write these as ratios. So I'm going to flip these all over. So I'm going to go negative 12 over 3, And I'm checking to see if that's equal to negative 16 over 4 and negative 20 over 5 and negative 24 over 6. So what is negative 12 divided by 3? Well, that'd be negative 4. And negative 16 divided by 4 is negative 4, and negative 20 divided by 5 is negative 4, and negative 24 divided by 6 is negative 4. So these are showing that there is a proportional relationship. So I'm going to cross off my two no's and I'm going to read my yeses. So yes, because all the ratios y to x are equal to negative 4. So y to x are equal to negative 4. So that seems like it's true. Yes, because all the ratios y to x are equal to negative 2. No, that's incorrect. They're not equal to negative 2. They are equal to this negative 4. Okay, so we would say these are proportional for that reason. Caroline swam 480 meters in 4 minutes. So I'm going to put 480 over 4. All right, and at what speed was she swimming? Because she's swimming at a constant speed. So they're doing the meters per minute. And so at what speed, you know, if you think miles per hour, that's usually the speed we think of. That's just per 1 hour. So we want this per 1 minute. And you can also see that by looking over here. It says per minute in all of our answers. So you can see what they want. So all you really have to do here is divide by 4, and you're going to get 120 meters per minute. Okay? All right, so what type of function does this equation below represent? So y equals 9 over x. So they don't give us a graph here. There's a couple of different ways here to look at this. But again, remember, in order for it to be directly proportional, so remember the differences here. If they're just proportional, like in this problem right here, proportional just means that all these ratios are equal. Okay. Now, if we're talking about directly proportional, that's when we want things that increase. You know, as x increases, y needs to increase. That would be directly proportional. Okay, so there's directly proportional, and there's inversely proportional. So we're trying to figure out which one's which, because they're asking for inversely, neither, or directly, or if it's not a function at all. And this is a function because we have two variables. So think about this here. I'm going to kind of make a separate, possibly easier problem here. If I think of 8 divided by 4, well, that's going to equal 2. Okay, and then I'm going to make another function that is also going to equal 2. Okay, that's going to be 16 divided by 8, and that equals 2. Okay, so let's take a look here at the first situation. First we started with a 4, and then we went to an 8, so that's an increase for my x value. And that would kind of correlate with this one here. Okay, notice how these two are the same, so that would correlate with my y. Now, what happens to this? Okay, as x increases from 4 to 8, this value here is also increasing from 8 to 16. Okay, so we would have an increase in this top number and an increase in the bottom number. Okay, but in our little situation here, we were changing both of these numbers, and the thing that was staying constant was the number outside, like this 2. Okay, so what that would look like would be y over x is equal to 2. Okay, so this sort of relationship here, we just proved that to be proportional. Okay, but what we have here is y equals 9 over x. Okay, so this 9 is not going to change. So let's think about this. If I had a 1 here, I would end up with a 9 here. 9 divided by 1 is 9. Okay, so now, because this is a 9, let's use a multiple of 3. So I'm going to say 9 divided by 3 is equal to 3. So what just happened? My x value increased, and my y value decreased. Okay, so whenever we have that happening, we say that we have an inversely proportional relationship. Okay, when x is increasing, y is decreasing. Okay, so that's the end of our lesson for today.